Hey y'all, welcome to lesson 1.5 about states of matter. Um, if you remember back from the last lesson, we said just very briefly that matter is anything that takes up space and has mass, so it has mass and volume. Um, and we also said that there were three types of matter. So today we're going to talk about those three states of matter. Sorry. So today we're going to talk about those three states of matter. Starting here at the bottom of your notes. All right, this should be the first page. We're down at the bottom. Um, but let's define that term state, right? States of matter. It doesn't mean like California, North Carolina, Alabama. But basically, a state is a distinct form in which matter can exist. Um, there are four. There's always some controversy about this. There are three that are really important. There are actually two that are eh. Um, but solid, liquid, gas are the three main ones that I know you have heard of. Plasma is often considered a fourth, um, and actually a fifth state of matter. A lot of people put glass and liquid crystal in their own state because they're not quite solid, they're not quite liquid. They're kind of a hybrid-y sort of thing. Anyway, if that seems to interest you, you can definitely do more research about that, about how glass is not technically a solid. Um, anyway, we are mostly going to be talking about solids, liquids, and gases. Those are the three that matter for this class. I will touch on plasma here in a minute. Um, but moving up a little bit, let's start with solids. In a solid, particles are closely packed together, um, so which is why they're solid, because all the elements, all the pieces are closely stuck together. Um, those particles, those atoms, cannot move freely. I'm sorry, that should say move. Can I change it? Yes. Not move freely, but they do vibrate. So if you look down at your computer right now or the table right now that your computer is sitting on, the atoms in that solid are vibrating back and forth. So they are moving back and forth. It's so tiny you can't see it, but they are. Um, Another thing about solids is they do have a definite shape and a definite volume, right? I can't take your chair and turn it into a different shape without a whole lot of force. Uh, it is what it is because it's a solid. Also, you can't change the volume of a solid um, without a whole lot of force. See, that's the next thing. Force must be used to change the shape. Right? Can't change the volume without ripping it in half or something like that. So, a couple of examples. You all know what a solid is: gold, silver, copper, the table, the floor, your body, most of it. Um, most of it that you can see, at least, anyway. Um, but those are solids, definite shape, definite volume. The next state of matter that we want to look at, I should have done this before, sorry. There we go. Makes it a little bigger. Anyway, the next state of matter we want to look at is liquid. Um, Particles are close together, but they have enough heat energy to move around each other freely. So you can take your bottle of water, I wish I had one, but I don't, um, and kind of tip it, and that water will move, right? Because it is warm enough, right? So we think about this in terms of water. Ice is solid water, right? It's cold. So that's what makes it a solid. And it has all the properties of a solid. Um, Water, in its liquid form, has all the properties of water, warmer than ice, right? So the heat energy is what makes it liquid. So literally, we could liquefy anything if we could get it hot enough to its melting point, to the point at which it would melt and become a liquid. It's a lot hotter for some things than it is for others, right? For sugar, it's not very hot. You can melt it on the stove fairly easily. Um, but for most solids, that's pretty high. It takes a lot of heat energy to melt it. Um, Liquids do have a definite volume, right? Your 2 liter. Oh, I do have some liquid right here. Oh, I just looked over it. See, so it's liquid, so it moves. But a 2 liter is 2 liters. Like that's the volume, regardless. It doesn't matter what container it's in, right? I spill this soda on the table. It's still the same amount of soda. So the volume is definite, does not change, right? But its shape will change. Like right here now, it's long and narrow. Here it's short and thicker, right? Um, but its volume is what its volume is. Um, so another term for liquid then is non-compressible fluids. Right? You can't compress them and make their volume any less. It is what it is. So examples of liquids: water, this soda, right? Mercury, methanol. Those are just some liquids. I want to pause for a second here and talk about ice because ice is special. It is different. Ice is one of the few things where the solid form is larger than the liquid form. Usually, when you freeze something, make it solid, it's smaller. The volume compresses, the particles come closer together. Like you can even see in this picture, the particles are close together. Here, they're spread out, right? But ice is different. The solid is usually larger than the liquid. Anyway, you can look up more information about that if you so desire. But let's move on and talk about gas. Gases, even warmer, right? Think about steam. It's because you've taken water and heated it even warmer, turned it into a gas. The particles are not at all close together, and they can move anywhere in their container. So if it's your kitchen, right, like those steam gas particles are moving all over. Or the oxygen in this room, right? It's not stuck at the top or at the bottom, it's anywhere, everywhere, right? So gases have no definite shape or volume. There's some examples: steam, helium, oxygen, things we've talked about, right? So when you hear about liquid nitrogen, that's nitrogen that has been made cold enough to freeze, which has to be super duper cold. Dry ice is just frozen carbon dioxide, so same thing. Just for a second, let's talk about plasma. Plasma is different because the particles are positively or negatively charged. So kind of think of like static cling with a positive and negative charge. They have extremely high kinetic energy, which means they are moving really fast. The particles are moving very, very fast. Just like a gas, no definite shape or volume, but they do conduct electricity. So some examples of plasma, not lava like some people think of, that is not a plasma. But lightning strikes, the insides of stars, including our own sun, neon signs, that in there is a plasma. It's basically a gas that has been positively or negatively charged. That is plasma. So that is lesson 1.5. You can go ahead and work on the assignment now, which I think is in Canvas, if I'm not mistaken.